Hi, I'm Kian, and in this video I'm going to show you how to solve this fun integral from the integration bee. So we have the integral from 0 to 1 of sine of inverse cosine of x. And I'm going to start by using the DI method, or the integration by parts. And then we have the plus, minus, plus, minus. So I'm going to differentiate our function, which is sine of inverse cosine x. And I'm going to integrate 1, because 1 multiplied by anything is itself. Integrating 1, it's x, and integrating our function, I'm going to use a chain rule, differentiating our function, I'm sorry. So we get cosine of cosine inverse of x. And then the derivative of inside is negative 1 over the square root of 1 minus x squared. And so we have to multiply these two and then subtract this. So I'm gonna need some space. So I'm gonna change my color to green. So this part is fairly easy, but this part, since the minuses cancel out, this becomes the integral plus. So the integral, and then cosine of inverse cosine x is just x. So this all cancel out. We have just x. So we have x squared, and then over the square root of 1 minus x squared dx. And now we can do a trigonometric substitution. So we can say that x is equal to cosine of theta, or I'm sorry, maybe you can use sine of theta. That's better. And then if we differentiate that, dx becomes cosine of theta. So this becomes the integral of sine squared theta. And then since we know that square root of sine squared is just cosine, and then times cosine, it cancels out. So we have just sine squared theta d theta. And now we can use a trig expression identity by knowing that cosine of 2x is actually cosine squared minus sine squared. So we know that cosine of 2x is 1 minus 2 sine squared x. So basically, we can say that a sine squared x is 1 minus cosine of 2x over 2. So this is basically the integral of 1/2 minus cosine of 2 theta over 2 d theta. And so this becomes 1/2 theta, but knowing that sine theta is equal to x, so theta is inverse sine of x. So we get 1/2 inverse sine of x. And then integrating this, we get negative 1/4 sine of 2 theta, or negative 1/2 sine theta times cosine theta. So sine theta is x, and then you have to multiply by cosine theta. But drawing a right triangle, we see that if this is theta, and then the sine of theta is x, by using Pythagorean theorem, we see that the cosine theta is actually, this side is 1 minus x squared. So this side becomes just square root of 1 minus x squared. And then all of these should be added to the x times sine of inverse cosine of x that we had from the start. Sine of inverse cosine of x. This is a little messy, I'm sorry. And then now you have to plug in the numbers. So I'm going to change this to this. So when we plug in 1, inverse sine of 1, we know that that's pi over 2. So you have actually pi over 4. And then we have 1. So 1/2 times 1 is 1, times the square root of 0 is 0. So that's good. And then plus the inverse cosine of 1. We know that inverse cosine is actually defined in quadrant 1 and 2. So inverse cosine of 1 is actually just 0. So sine of 0 is 0. So all of these become pi over 4. And then minus, when we plug in 0, so inverse sine of 0, this is just 0. And then minus, this becomes also 0. Plus inverse cosine of 0 is actually pi over 2. And then sine of pi over 2 is 1. But times 0 is 0. So we have minus 0. So our final answer should be pi over 4. And thank you for watching. Please subscribe to my channel so I can make more videos on different math topics. And goodbye.